Hey guys, we're just gonna go over the comp test, which is tomorrow. That's why I'm doing the video now, because I procrastinate as well. Leave me alone. On that, let's go ahead and get started. The very first proof is right over here. If you guys took a look at the solution manual, which is on the same page as the test, it kind of gives you the reasoning, but I'll actually work it out. So first you have to define four different letters or variables for these guys. Alright, so you say let m equal to a over b, where a is rational and b is rational, where b cannot be equal to 0. You do the exact same thing for n, but n it's c and d, where blah blah blah, and d is not equal to 0. So then, all you do is you substitute it in. So you have 3 divided by a, b, subtract c, d. And then you want to get a common denominator. So you just make that 3bd, bd. And if you multiply this through, you get, I believe it's AD minus CB. Alright. And now this is pretty much the solution. We just have one more step. All you do is you say let 3BD be equal to Q, AD minus CB equal to P. Therefore, this is equal to Q over P, where P cannot be equal to 0 because none of these terms are 0. Alright, and yeah, so now, because of that, you know that since P is an integer and, rational integer, oops. You know that p and q integers, a integer divided by integer is a integer, and m cannot be equal to n because of this stated over here. So you basically proved that one already. That one wasn't bad at all. The next one's a little bit harder. Now, this is saying if a implies b. I'm going to do the contrapositive and say not b implies not a. So why don't we go ahead and write that down. So assume if 5, then 5 squared n squared. Alright, this is a contrapositive. Alright, since we assume that that's true, we can work with it. Since we know 5 is divisible by n, then n and 5, since 5 is a prime number, that's very important. Since 5 is a prime number, you know that n has to be some multiple of 5. So you can say that n is equal to 5k, where k is any integer. Where k is an element of integers, right? And if you can say that, and if you just write next step, you just square both sides, you get n squared is equal to 25k squared. So, if you have 5 squared over n squared, you know this is going to be 25k squared, right? Because of this relationship. You can therefore say that 25 is equal to 5 squared over n squared, and thus, by proving contrapositive, if 5, then 5n. Alright, this one is the more difficult one. First of all, you have to realize that there's an if and only if. Well, what does that mean? Well, that means A implies B and B implies A. So not only do you have to prove that A implies B, you have to prove B implies A. So prove that 5n plus 3 is even, and 3n plus 2 is odd. Okay, so how exactly do we do that? Prove that 5n plus 3 is even if and only if 3n plus 2 is odd. So you know what? Let's first start by making 3n plus 2 an odd number. Well, how do we make that odd number? All we gotta do, since we know that odd is actually 2k plus 1, where k is some integer. K is some integer. And that's the same thing over here. 5n plus 3 is equal to 2k. That's the definition of even. You can't actually write k in this case because these two variables will most likely not be the same. They could be, I didn't check, but they'll most likely not be the same. So let's go ahead and make this as, let's make it a z. Alright, so z is an element of integers as well. Now the next step is, all you gotta do is substitute one to the other. So I'll go ahead and do this one, just because I feel like it. And we're gonna solve for n, so we're gonna isolate for n. So we'll get 2k minus 1 over 3. We're then going to substitute this guy into this guy. So you get 5, 2k minus 1 over 3 plus 3 is equal to 2z. We're going to get rid of this 3 down here. So we'll multiply everything by 3. So you'll get 5, 2k minus 1 plus 9 is equal to 6z. And we're just going to expand this out, so we get 10k minus 5 plus 9 is equal to 6z. And if you do some more stuff, you get 10k minus, plus 4 is equal to 6z. Now, if you guys see, you know this for sure will always be even, and this for sure will always be even because you're multiplying something by 10 and adding 4 to it. But you'll actually lose marks if you do that, because you didn't actually prove that an even plus an even is an even. So the only definition we know is that 2k is even, right? Or 2z in this case, because that's how I defined it. So we need to somehow prove that this is even. Alright, well how do we do that? Well, we know 2 times any integer is even. So all you do is factor to 2, and you get 5k plus 4. Right? And you're going to do the same thing over here. You're going to factor a number, you're going to factor to 2, and you get 3z. Well, if you let 5k plus 4, I don't know, let's make that r, and then you get an element of a real integers, and let's say s. That looks too much like a 5. What? B, sure. You can say that 2 times a number, so I guess what I use r in this case, yeah, sure. 2 times r is equal to 2b. And because you know that, since 3n plus 2 was odd, this will always be even, or z will always be even, because you factor out, right? So therefore you proved that if you proved if A then B. Now all you gotta do is do the other way around and substitute the other one to the other equation. I'm not going to do that because it's just more work for me, but that is, I believe, how you solve the situation. I meant question. Yeah, how you solve the question. Alright, I'm going to move on to the other questions, but there's going to be a little quick break in the video. See you guys soon.